There's a $10 fix sitting inside almost every portable air conditioner in America that can straight up double how well it cools your room. And I mean that literally double, not some marginal 5% improvement. You'd need a lab to notice. We're talking about turning a unit that's basically burning your money into one that actually competes with a system costing 10 times as much. And the fix takes maybe 20 minutes with stuff you can grab from a hardware store. Picture this. It's the middle of July. You got a portable AC unit running full blast in your apartment, and your electric bill still comes in looking like you left every window open on purpose. You crank it up, it runs constantly, and the room never quite gets as cold as you want it. You start wondering if the unit's just cheap junk, or if you got scammed, or if portable ACs are simply a bad idea altogether. None of that's actually true. What's actually happening is a basic physics problem built into almost every single-hose portable AC on the market, and it's fixable in an afternoon. Here's the thing that's going to make you a little mad once you understand it. Nearly every portable AC unit rolling off the factory line ships with a design flaw baked right in. Not a cheap parts problem. Not a bad compressor problem. A basic airflow problem that manufacturers have known about for years and just never fixed. And once you see why, you're going to understand exactly why portable units have this reputation for being expensive to run compared to a proper split system, even though under the hood, they're using almost the exact same core technology. Let's actually get into what's going on inside these things, because once you see it, the fix is going to feel almost too simple. First, let's talk about the two basic categories of AC you're choosing between. You've got portable single-hose units, the ones with one exhaust hose you run out a window. And you've got split systems, the kind with an indoor unit and a separate outdoor compressor box, no hose running through your window at all. There are hybrid setups too these days that try to blend the two. But for now, let's focus on the two main players, because understanding the difference is exactly what's going to make this whole hack click for you. Both of these systems, underneath all the plastic and branding, are running the same basic refrigeration cycle. There's a refrigerant fluid cycling through the system, and it absorbs heat from your room and dumps it outside through a phase change, going from liquid to gas and back again as it moves heat from point A to point B. The core components doing that job, the compressor, the expansion valve, the heat exchangers, are functionally the same whether you're looking at a $2,000 split system or a $300 box you bought at a big box store. The real difference isn't really the technology. It's where each component physically lives. In a split system, the loud stuff, the compressor, the expansion valve, sits outside in that separate unit. Your neighbors deal with the noise, not you. Inside, all you've got is the quiet evaporator coil and a fan blowing cool air into your room. Clean, simple, quiet. In a portable monoblock unit, everything's crammed into one box, sitting right there in your living room. Every noisy part is now inside with you. And there's a second issue nobody talks about enough. Some of those components generate a bit of waste heat as they run, and in a split system that waste heat gets dumped outside with the compressor in a portable unit. Guess where that leftover heat ends up? Right back in the room you're trying to cool. That's a real efficiency hit, and it's baked into the basic design. No simple fix changes that particular problem. But there's a much bigger factor working against portable units, and this one you can actually fix yourself. It's airflow. Specifically, it's how these units are pulling air in. Here's what's actually happening inside a single-hose portable AC. The unit pulls in room air and splits it into two separate streams. One stream gets cooled down and blown right back into your room. That's the part doing the actual cooling you feel. The other stream gets loaded up with all that excess heat and pushed out through that exhaust hose hanging out your window. Sounds fine on paper, right? Here's the catch. Every single cubic foot of air that gets pushed outside through that hose has to get replaced by something. Air doesn't just disappear from a room. Physics doesn't work that way. So as the unit blows air out, it creates a slight negative pressure inside your room. And that negative pressure pulls air back in from literally anywhere it can find a gap. Door cracks, window seals, any tiny opening in your house. And that air coming back in, it's warm air from outside. In the worst case scenario, some of it might genuinely be a portion of the exact same hot exhaust air that just got pushed out seconds earlier, getting sucked right back around and pulled back inside. You're paying to cool air, blowing the heat outside, and then immediately re-inviting fresh warm air back in to replace it. It's like bailing water out of a boat with a hole in the bottom. Think about it like this for a second. Imagine trying to empty a bathtub with a bucket, while someone's standing there with a hose, refilling it at almost the same rate you're bailing it out. Technically, you're doing work. Technically, water is leaving the tub, but you're never actually winning because the input keeps matching the output. That's basically what a single-hose portable AC is doing with heat all day long, every single cooling cycle. This is the actual reason split systems can run circles around portable units in real-world efficiency. We're talking up to 7 times more efficient in practice, not just a little bit better. And that difference shows up directly in your electric bill. A portable single-hose unit running a full week of cooling can cost you noticeably more than a split system doing the exact same job over that same week. We're talking a genuinely dramatic gap, not pocket change. So here's the obvious question. If you can afford to get a split system professionally installed from a pure efficiency and long-term cost standpoint, that's genuinely the better move. It costs more up front, sure, but it makes that money back through way cheaper operation. And these systems tend to last longer too. But a lot of us are renting. A lot of us can't drill holes in walls or hire someone to mount an outdoor compressor unit. And that's exactly where this gets interesting, because it turns out you can fix a huge chunk of that portable unit's efficiency problem yourself without any of that. Here's how the intake side of a portable AC actually works. It pulls air into the outer casing, and there are 2 separate intake points doing 2 different jobs. One intake pulls in the room air that's about to get cooled. That's called the evaporator intake. The other intake pulls in air specifically to cool the condenser side of the system, and that's the one we care about here. Usually, both of these are located on the back or side of the unit, often tucked behind a filter panel down near the bottom. The fix is genuinely simple once you find the right intake. You need to identify specifically which opening is a condenser intake, not the evaporator intake. That's a different job entirely, and build a simple box or duct around just that one opening. Thin plastic, rigid foam board, plywood, whatever you got lying around works fine. If you want it to look clean, you can even get fancy with a custom-fitted adapter, but honestly, even a cardboard box duct taped into place gets the job done. It won't win any design awards, but it flat out works, and setups built this crudely have run for years without a hitch. Here's the one detail that actually matters, so pay attention. That box has to cover only the condenser intake. If you accidentally seal off the evaporator intake too, the one pulling in room air to actually cool, your unit's cooling performance tanks immediately, or in some cases, it can even start icing up internally. So take your time identifying exactly which opening is which before you start building anything. Once you got your box built, seal the edges up as tight as you reasonably can. Basic window weather stripping works great for this. Honestly, even cheap packing tape does the job in a pinch. One thing worth keeping in mind while you're sealing it up: try to leave yourself some way to still access the filter behind there, because you're going to want to clean that periodically, and you don't want to have to tear the whole setup apart every time. After that, the only thing left to buy is a second exhaust hose, basically identical to the one that came with your unit. And you connect that as an intake hose running into the box you just built. That's genuinely the only real cost in this entire project. And depending on the quality of hose you go with, you're looking at somewhere around $10, give or take. Last step, and this is where it all comes together. Run both hoses out the window, positioned as far apart from each other as you reasonably can. One's your original exhaust, pushing hot air out. The other's your new intake, pulling outside air and specifically to feed that condenser. Get that setup right, and you essentially converted a cheap single-hose unit into a proper dual-hose system. A couple things worth knowing before you fire it up for the first time. If you notice the unit seems to be working harder, but the room isn't actually getting colder, double-check you haven't accidentally boxed in that evaporator intake by mistake. That's genuinely the single most common error people make on this build, since the 2 intakes can sit pretty close together depending on the model. Also worth doing a quick visual check on your seal job after the first day of running it. Foam bore intake can shift slightly as a unit vibrates during normal operation, and a small gap reopening defeats a chunk of what you just built. Done correctly, this can genuinely come close to doubling your unit's real-world performance. Even on a conservative end, you should expect somewhere in the range of a 30 to 60% efficiency improvement. Though results are absolutely going to vary depending on your specific unit, how you're running it, and the characteristics of the room you're cooling. What's actually happening here is that your condenser is now pulling controlled air from outside instead of fighting that negative pressure problem we talked about earlier. That whole issue that was tanking portable AC efficiency in the first place is basically solved with $10 and a cardboard box. So here's the question that's probably bugging you now. If this fix is as simple and this cheap, why doesn't every single portable AC just ship with 2 hoses from the factory? Genuinely, from a pure thermodynamics and energy efficiency standpoint, there's no good technical argument against it. A unit running dual hoses for both intake and exhaust is functionally superior in basically every real-world scenario compared to a single hose setup. So, why doesn't it happen by default? Our best read on it comes down to how efficiency ratings actually get measured and labeled. In a lot of regions, both single hose and dual hose units get evaluated using the same basic lab efficiency rating system, a control lab measurement that, critically, doesn't really account for that real-world negative pressure problem we've been talking about this whole video. In a sealed lab test environment, that pressure differential barely matters. Out in your actual living room, with actual door gaps and window seals, it matters a lot. That's a real gap in how these ratings get calculated. And it means the rating on the box doesn't necessarily reflect how the unit's going to perform once it's fighting real-world air leakage in your actual home, which basically means the burden falls on you, the buyer, to either know about this going in or to buy the cheaper single-hose unit and handle the upgrade yourself. We think the dual-hose mod is genuinely worth doing for most people running a single-hose unit. But fair warning here, you're doing this at your own risk. And if you're not confident working with basic tools, or you're renting somewhere with strict rules about modifications, factor that in before you start cutting foam board. And honestly, this whole hack gets even more interesting once you factor in how cheap some of these base units have gotten. We ran the numbers on a handful of budget portable units, completely separate from the dual hose mod, just comparing raw upfront costs against a proper split system. And the surprising part is that even without any modification at all, a genuinely cheap portable unit used sensibly can hold its own against a far pricier split system, purely because the upfront cost gap is so massive. Add the dual hose mod on top of that, and the math gets even more lopsided in favor of the cheap unit. You're now closing a big chunk of the efficiency gap too, on top of already winning on sticker price. If you're renting, dealing with a landlord who won't let you install a split system, or you just don't want to drop the money on professional installation right now, this is genuinely one of the highest value 20-minute projects you can do this summer. $10, some scrap material, a little patience finding the right intake, and you've got yourself a portable AC that's not fighting itself anymore. Worth mentioning too, this mod tends to matter most for exactly the situation most people are actually in, a smaller bedroom or a studio apartment where the AC is running for hours at a stretch, day after day, all summer long. If you're only running a portable unit occasionally, for an hour here or there, the extra effort might not be worth chasing down for you specifically. But if that unit is basically your primary cooling system for the whole season, this fix pays for itself in the first week and keeps paying you back every single day after that. It's also worth being upfront that not every single unit responds identically to this. Some manufacturers already designed their intake placement a little more sensibly than others, so your mileage really can vary from one model to the next. But across the units people have tried this on, the pattern holds up consistently enough that it's worth the 20 minutes to at least try it on whatever you've already got sitting in your window right now. If this was useful, subscribing helps a ton because we got a bunch more of these practical, cheap efficiency fixes lined up. Drop a comment and let me know if you've got a portable unit at home right now. Because if you do, this fix is probably sitting there waiting for you to try it tonight. See you in the next one.